Hello everyone. We are going to be looking at chapter 7, which deals with managing project resources. By considering resources required for each of the project activities and tasks, and also by considering the availability of those resources, we can put together an optimized project schedule that optimizes the use of resources. If we don't manage resources properly, our project will not only cost more, but it can also be facing cancellation, as we will see in a minute. These are the learning objectives for this chapter. You will recognize various types of resources. You will also understand the importance of managing resources and their impact on project schedule. You will apply project resource management tools and techniques for managing project time and project resources. The case included in the textbook is about London Olympics in 2012. This is when the Olympics Committee decided that they wanted to offer the games digitally. For this, they had to deploy many new techniques like 3D cameras, remotely controlled cameras, also developing their own app for true live experience of the games. They also had to contract with a number of audiovisual companies to work together in delivery of all these services, the digital services that they had planned. As a good example and as a success story, of course, all of that came together and they had a wonderful 2012 Olympics. Let's first look at the different types of resources that the project may need. People or human resources involved in the project have a great bearing on its success. People with different skill sets are required for most projects. People with skills like business analysts, architects, or developers. In many cases, the organization does not have all the required skill sets in the organization, and therefore those expertise need to be brought on board as contractors. IT projects are also require equipment to run on, such as servers, the IT infrastructure, the operating system in the data center or in the cloud. Of course, if the project is using external products or services for the project, there needs to be money to purchase and procure those services and products. Projects may also need other technologies for, say, data analytics or AI. The project team may need to consider all resources, or should consider all resources that are required for the project, and make sure that the project plan considers the need for all of those resources. Capital resources are referred to tools and infrastructure that are used by an organization to produce other goods and services that organization delivers. For example, SPSS, which is a statistical software, and the infrastructure that is required for it to run, be it on servers or on the cloud, can be capital resource, an example of capital resource for a project. Similarly, space, the physical space, the offices and places, and also the technology that is used by projects are all capital resources. And these capital resources are best managed across the organization when we have the information about all the projects that use those resources. Management of capital resources is particularly important when you consider the opportunity cost, which is defined as the value of opportunity foregone. For example, if you go to a movie, what is the opportunity cost associated with that? Well, you could have spent the time that you went to a movie doing other things, maybe more pleasurable, maybe reading a book. You could also spend the money that you spend there on other things. So organizations obviously want to be aware of the opportunity cost when various projects are using the capital resources in the organization, and want to make sure that the maximum value is drawn from those resources. When we manage project resources, there are a number of things that we need to keep in mind. Let's first talk about what is the importance of managing resources, and how does the managing resources and the project life cycle, how does it map on the project life cycle. And also we will talk about the concept of duration versus the length of the effort. Resource management is quite critical in project management because it impacts all of the key objectives of the project. A poor resource management not only causes longer schedule, but also costs more. The project costs more, and in many cases it can also impact the quality of the project. Organizations typically are very conscious and pay attention to resource management, and a project that does not manage resources effectively is considered wasteful by management, and the project is at the risk of being cancelled. There are a number of challenges when we are doing resource management that we have to be aware of. Changes in availability of resources is quite frequent. We have planned for resources, but maybe the resources leave the organization or move to another project. There are also certain resources that are scarce, and a project has to compete for these resources with other projects. For example, in many organizations, the development staff are in high demand, and good development staff, different projects are competing to get them on their own project. Global projects introduce many of their own challenges. These are the projects where the project team members are dispersed geographically or time-wise. Motorola, it's a company that has extensive experience in distributed development teams and international teams, has identified 10 challenges associated with global development teams. These are listed under the issues in this table, and And then for those 10 challenges, Motorola identified 12 strategies that are shown on the top of this table to address those challenges. For example, to address software integration challenge, they assign a team liaison to improve the communication. They have continuous communication with the team members, and they establish architectural principles and many other things, as you can see on this table. So the resource management life cycle falls into similar phases that we have talked about in project management, and we need to assign resources to each activity. That's part of the planning phase. And we also need to consider the availability of resources while we are planning our project schedule, and those are all input to our project schedule. During execution, we may need to reallocate resources, move resources around to areas that are falling behind to help them catch up with the rest of the project. This slide illustrates how the resources needed and their availability need to be considered to accurately estimate the duration of activities. So we know the resource needs, and we, based on the availability of resources, then we can determine the duration of that activity based on, again, availability of that resource. This is a process map for estimating resources required for activities. There are a number of estimating techniques that we'll look in a second. The process produces the resource breakdown structure, which is one of the deliverables out of this process. These are the various estimating techniques for estimating resources. It's very similar to techniques we use for estimating other aspects of the project. Let's spend a few minutes and talk about some of these. Expert judgment, as suggested by its name, is the estimate made by experts for that particular activities that we are considering. Sometimes there are estimating guides available. For example, for EHR systems, you can look up what's the average cost of implementing an EHR system. Sometimes we need to break down an activity to smaller pieces to be able to estimate required resources to develop a bottom-up estimate, building up from pieces, bottom-up estimate. Sometimes we can use estimates for similar components or modules. This is called analogous estimate. If we need to build an interface between two systems, maybe we have done that for in similar cases, and we can use the actual cost that we incurred for those interfaces. If we have the estimate for a task that is smaller or bigger than the task for which we need to estimate the resources, we can use parametric estimates. Is this twice as big or maybe half as big? And then accordingly we can adjust the estimate. We also need to consider alternatives when we are estimating the required resources, and in some cases, to optimize the schedule, we may need to consider alternative ways, for example outsourcing an activity if that particular activity is a bottleneck for our project. This is the process map for estimating activity durations. Again, there are a number of estimating techniques that we will take a look at. One of the additional estimating techniques, in addition to what we have talked about, is reserve analysis. This is where we determine if we need some reserve, basically time cushion, for certain activities that, for example, depend on scarce resources. 3-point estimating is a form of quantitative estimating, and it increases the accuracy of the estimate by considering the optimistic, pessimistic, and most likely estimates and combining those to come up with a better estimate. PERT is one of the is an example or one form of 3-point estimating, and this is the formula for PERT. In PERT distribution, basically weighted average is computed with the formula shown, which gives a factor of 4 to the most likely estimate, while it calculating the average by adding the optimistic and pessimistic estimates as well. So this is the process map for developing the schedule, and I think we have talked about all of these elements in one way or the other. One thing that we have not talked about perhaps as much is Monte Carlo simulation, which is based on some probability of the resources needed for an activity. We can bring in the probability analysis for various tasks and then come up with a much more accurate estimate for the overall project. To calculate the durations correctly, we need to make sure that the working time, such as the weekdays, not the weekends, is specified in the project schedule so that it's clear that the individuals are only available, for example, during the weekdays. We have talked about critical path in the past, and one of the scheduling technique is, of course, to determine the critical path, which is defined as the longest path through a network that establishes the shortest time that the project can get done. For this simple network diagram example that we have, we can calculate various paths between nodes 1 and node 7 by calculating the duration of each path. In this example, we see that AEGI is the longest path, that it takes 12 days, which is also the shortest time that this project can get done. Of course, a Microsoft project can automatically calculate the critical path and highlight it in the network diagram. As you can see, the activities that are shown in red are critical, show the critical path. When we develop the project schedule, some activities may have free slack, which is the time they can be delayed without impacting the immediately following activities. So that's free slack. The time that activity can be delayed without impacting the completion of a project is called total slack. So depending on if we're looking at the impact on immediate activities or overall project, that's where the slack is computed for an activity. To compress our schedule, there are a couple of ways that we can do that. We need to, sometimes we need to parallel some activities. This is called fast tracking. We may also shorten the duration of some activities by assigning more resources to that activity, and that's called crashing the schedule. So these are two different techniques for shortening our schedule. Sometimes the demand for a resource exceeds the availability of that resource. For example, if we have only one nurse to participate in a project, but the tasks for that project require 2 nurses, we will need to stretch the duration of the tasks requiring the nurse so that our need for the nurse does not exceed 1 nurse at any point in our schedule. So that's the resource constraint that we have to apply, and as a result, the activities get longer, and that's to level the resource needs in the project. Like other PM processes, schedule needs to be controlled. One of the key tools for controlling schedule is reviewing the work performed of resources and adjust as real performance information become available. And if that's different from our estimates, then we need to adjust our resources or reallocate our resources. So that's part of the control activity. So that concludes our discussion on resource management and its impact on the schedule. Thank you for your attention.